When began studying computer science at the undergraduate level, uh, I looked at my schedule of classes and it said to take this math class, this physics class, and this computer science class. And then I looked at my next semester of classes and I took them, and I didn't see any rhyme or reason. I just kind of took this first series of classes, then the second series of classes, and the third series of classes. And it wasn't until I began teaching, or I'm sorry, not began teaching, but like was well into my teaching career and adopted the project-based pedagogy, that I understood that what I do in the classroom is kind of the same thing as what is happening at the university level, right? So what am I doing in the classroom? Well, what I do, like let's say for the intro to coding class, I created a final project, right, which was the construction of a game using Pygame. And then I broke that down and I said, okay, what do the students need to know in order to construct that game? And then I went ahead and created Pong, Density, and Raiden, which kind of gave you the tools to construct a game independently. And then I went and looked at Pong and I said, okay, what do the students need to know in order to do that? And then I created a bunch of sub-projects that led up to the skills that were needed to complete Pong. And so that's kind of the way that I put together that curriculum. And then now thinking back and looking back at my experience at undergraduate computer science program, it's the same thing, right? I now see that the culminating project is the operating systems class and the compilers class, and so those are the two classes at the end of your 4 years that you take. And basically every class that you take before that are giving you the tools to complete these two classes successfully. And so what is the operating systems class? You study about operating systems and you also build a portion of one, right? And then what about the compiler class? Well, you build a compiler. And so what is a compiler? It is a program that runs a high-level language like C++ or Java, Python. Python is uses an interpreter, but same idea. And so what skills do you need to know in order to create a compiler, right? Well, what does a compiler do? It turns C++ into ones and zeros. Right? And so you need to know how high level code works. And what is high level code? It is C++, Java, Python. You need to know how assembly language works. And what is assembly language? It is what high level code is turned into before turning it into machine language, which is ones and zeros. Right? And so we could see here do I have a picture? Yes, here we go. So here is a picture of assembly language, right? So it takes this high-level language program and turns it into assembly language here, right? And then once you know how machine language works, right, then you need to know how a computer can perform different functions based on machine language, based on ones and zeros, based on pulses of electrical charges, which represent on and off. And so what did Shannon do? He created the groundwork for the construction of a machine that can perform different functions based on pulses of electrical charge. Right? And how did he do that? By seeing the connection between electrical switches and the Boolean laws. And so we're going to need to dive a little bit deeper into the Boolean laws and switches, and then we're going to do that in the next task. And before we watch a documentary on Shannon, so it just gives us a little bit of background information so that we can really appreciate what he has added to the field of computer science.